So my name is Soren Sprissler. I'm currently working at AMAT as an application engineer. So I'm just going to go through a little presentation here. On the agenda we have my biography and then a little work history. So I come from Appleton, Wisconsin. It's a little tiny town up north between Green Bay and Oshkosh. Everybody knows the Green Bay Packers, Aaron Rodgers. Come from a big family. I got 4 brothers. Teaches you a lot of things about patience, and but we're a tight-knit family. From there, my educational journey has been a long one. I started out going to Fox Valley Technical College. From there, went to UW Milwaukee. Spent a year there. Actually failed out both semesters. So I got a 0.925 and a 0.975. At which point, the Twin Towers came down, my dad lost his job, and they moved to Texas. So it said you can either find your own way, and I had a job as a Cutco knife salesman, if you guys ever looking to buy some knives. Or you can come back down and restart your life. So that's what I did. Came back down, got my residency here, did some ACC, getting my core credits and trying to get everything back up to engineering standards, 3.0 and above. During that time, I had a baby. I had my daughter, Adele, in 2006. And then, originally I wanted to be a biomedical engineer. I wanted to work with prosthetics and get into the biometrics and electrical prosthesis. But UT didn't want me, so. I geared everything up. I did all my biology, all my chemistry, all my physics, all my mathematics, gearing towards that. They denied me, so then I had to take that and kind of see what I could go do. At the time, Texas State had a new engineering program that they just started up. And so there's a picture of me, Ivan, and Brandon. We were working in our senior year in the Advanced Electroceramics Lab. And what we were doing was creating a material called CCTO, which had really good capacitance, and they wanted to put this in. It was an Air Force grant budget, Air Force grant that my professor got, and we were pressing this material and then doing some diagnostics and characterization of the material. And to do that, we also had to do some sputtering. So I don't know if you guys know what that is. It's where you take a material, create a plasma, and then it makes this very thin film on the material. So we were doing that on the CCTO to be able to do our characterization. Like I said, I was one of the first through the program. So I always like to say that I'm in the top 3 in my graduating class. I'm number 3. So Ivan was very, very smart. He was number 1. Kyle Kastner was number 2, and then I was number 3. So professionally, because I had the background in sputtering and the CCTO and the electronics lab, I actually went to a Women in Engineering, Women in Technology presentation, and was able to give my resume to an individual from Samsung, and that's how I got my job. So always go to these events and always, keep putting yourself out there and keep trying to learn. So from there, I came into Samsung in 2011 in July. And we did the 40 to 5 nanometer startup. It was the fastest 300 millimeter startup. We did it in about 6 months. We were pulling about 80-hour days, or 80-hour weeks, and it was a massive effort. amongst everybody. So I started out as an equipment engineer. Then after about 5 years, I moved over to an innovation engineer, got my project management professional certificate. And then just recently, before I moved over to AMAT, I went back to school. So I always want to emphasize, when you're in science and technology, you want to keep up to date with all the new technology and the new things that are happening out there. So I went back to UT Data Boot Camp and learned some coding. And that kind of catapulted me into my new position where I'm at AMAT as an application engineer. And then outside of work, I like basketball, skiing, downhill mountain biking, golf, triathlete. Did a half Ironman back in October 2021. Teeth. So some of the stuff that I did at Samsung was that we would create these task force teams, right? And one of the things that we did was every department had robots, right? So we created a team that kind of controlled the standards and the documentation and the maintenance and everything associated with robots. So I led a team, doing a lot of work. So when I got into corporate America, I did not know that they exclusively use Excel. So if I can tell you guys one thing, learn Excel. It is your best friend. It'll save you so much time. When I was growing up, they're like, oh, it was like how fast you could type, and like know your home row, and like learning how to type without looking down, right? Now everything is Excel. You gotta know your formulas, you gotta know your VLOOKUPs, you gotta know your pivot tables. The better you can be in Excel, you will be light years ahead of your competition moving into your work, right? So at Samsung, everything. All your data pulls, all your data connections from servers and databases to Excel, everything is driven by APIs now and your databases, right? So learn as much as you can about Excel. So I did that for a little while. We went through our methodology, we created our standards and did all that stuff. And then in the innovation team, that led me into working on the AT&T Samsung 5G Innovation Zone. So that was a little side project that we had at Samsung. If you come visit the site, you can come walk through and kind of do a history of Samsung. You can walk through an air shower, do a lot of that stuff. But they also wanted to kind of promote the 5G capability, and everybody's kind of moving towards that, right? But, and what we could do with 5G in our fab, right? Within our facility, how can we utilize and capitalize on that data communication? So what I was responsible for was this robot case. And so I had to take an old robot that was down in the basement, that was just kind of sitting there, revitalize it, build this, we had a company, a third-party company build the case, but then I had to program it and to move it from the FOUP to a wafer station that I created with some laser cutouts and then what we wanted to demonstrate was the vibration sensors, right? So we were trying to incorporate vibration sensors into the robots to kind of give you a feedback of when all these movements happen, right? If you're seeing a little bit of chatter or a little bit of increased vibration within your movements, you know, you have loose screws, or you can, a lot of them are driven by lead screws, right? So they'll kind of, if your lead screw isn't greased well enough, or if it's somehow bent, you'll kind of get that chatter. So we wanted to be able to go from It's a run-to-fail state is what we do for robots at Samsung. It's hard to predict when they're going to fail, and it's a big job to actually take a tool down to replace a robot. So having more sensors as far as like vibration sensors and everything on those robots can lead you to make better decisions as far as when to replace it, so that you don't have uncalled for downtime, right? And with semiconductor, it's all about your uptime. Now that kind of led into another project, which was a vibration wafer. So this vibration wafer up in the right-hand corner allows the wafer to go and travel as if it were a normal wafer. So the thickness of the electronics on top of it was 2.8 millimeters to be able to allow it to go through the tool without having us to open up chambers. So once again, we were able to get with the third-party company. This is InterSense. And what you get is this, they turn out to be FFTs, fast Fourier transforms, and then they kind of do their analysis within that. And you can kind of track the wafer as it goes from a pick position to an up position to a back position, and you can actually like trace the wafer all the way through. And then you can put statistical process controls around that and use historical data to kind of put some warning bands and some critical alarm limits on it to tell you when something was going to go bad, right? So in the semiconductor world, the biggest thing that you want to do is you want to be able to predict things that are going to happen. You don't want to be kind of reactionary to a situation where the tool is down and you don't know what to do, and then you have to like scramble to try to fix it. We call putting the fires out, but this is a way where we can go from reactive to predictive maintenance, and that's the biggest thing in that world is being in control, knowing your downtimes, knowing how long it's going to be, and then getting back up and running and having everything have the same repeatability and reliability in your process, right? So this is just kind of an overview of my roles and responsibilities. This is the actual FOUP that the wafer would go in. So it used fiber optics from the wafer to the FOUP, and it would send data from, you'd tell the wafer to start, it would go out, it would run through the tool, it would come back into the FOUP. The FOUP would do the fiber optic data transfer, and then it would go from the FOUP onto the loading dock over here on the bottom right. From there, an RS-232 connector would come up, connect to the FOUP. That would go to our systems and upload all the data into our databases, and then allow our engineers from the outside to access that program and then be able to see all the data. So it's a very cool project, but it was also a lot of work because not only do you have to work with the hardware aspect of it, but you got to work with the back end and the databases and the software and getting everything to communicate and so on and so forth. So this was more of just a continuation of that project. For those that don't know, this is a picture of what we call a tool. So it isn't like your wrench or your your screwdriver. What we call a tool is normally like a platform. There's a lot of different companies out there, AMAT, Lam, in photo there's Tokyo Electron, so on and so forth, right? But yeah, each one of those is a chamber, and the load ports are in front, so the wafer goes through the load port, through the EFEM, and then goes through your mainframe and throughout the chambers. And then this is the statistical process control that I was talking about earlier, where the vibration wafer can use the historical data and give you an indication of when, if you're out, your robot end effector might have a little vibration on it, When it comes back in, maybe it doesn't, right? Because it's a little bit closer. But knowing and being able to track all the trends within your system without having to open it up is extremely beneficial to have that data feedback. And then outside of that, I just wanted to talk about how important it is to continue your education. I know a lot of you guys are in school and, you know, kind of gets old and kind of gets boring, but as you get into corporate America, you also find that there's a lot of monotony and your job kind of gets not boring, but it's just the same stuff over and over. At some point, you're kind of like itching for something new, right? So always try to keep learning. This is some of the overview of the data boot camp that I did. We did machine learning, which is really cool, which is the TensorFlow stuff. And just keeping up with the new technology. And so that's about all I have. If you guys have any questions for me or yeah.
So you talked a lot about how you have to have so many different elements handshake together. Essentially, do you have any issues like delay or lag, and how do you start approaching that?
Delay or lag in communication with our systems? Yeah. Oh, so one thing that Samsung did was really well was teach me how to troubleshoot, and that's what you guys are going to learn as you go into corporate America. Right now, you know, through school, you guys are learning how to learn, right? What's the best way to retain this information? How do I apply it, right? So, at least in the semiconductor industry and most technology jobs, you're going to learn how to troubleshoot. So within that, we look at our bottlenecks. You identify originally where does it stop, and within that, what I've learned in troubleshooting is your end signal is not always what is the problem, right? It's just the indicator showing you, hey, this is what faulted, but it may be 3 steps back that the issue really was, right? So with troubleshooting and with anything, you have to know your system as a whole, right? You can't just look at a robot and say, oh, well, a wafer broke, and you know, it was because the robot smashed into the wafer. Well, why was the wafer in the wrong position? Why was, then you have to go backwards. Okay, well, you know, this lifter didn't go up all the way. Well, why didn't that go up all the way? Well, the flight sensor got bumped during maintenance. Well, why did that get, you know, so it's just this lineage of different things that could happen, and I'm sure you guys have this with your robotics, of like, you guys made a change and all of a sudden we were working and then we're not working. Why are we not working? Or like, you know, you make an update to software and it doesn't, you may fix one thing, but you also didn't think, well, maybe this was a global variable and it hit this one too, and now it doesn't work. And now you're sitting there scratching your head, right? So, not getting, you know, your horse blinders on and kind of super attached to an end result is really, for me, which was good to learn in troubleshooting. It's just like, okay, and there's different techniques. There's like fishbone, like, okay, we started this timeline, where did it go wrong? You know, stuff like that. So, and as far as, you know, figuring stuff out, you just have to be humble. You're like, sometimes you don't know. You gotta ask for help. Biggest thing for me was like learning how to ask for help. Samsung, there's a lot of smart people, right? So I knew I wasn't the smartest, but I'm approachable and I like to, I'm friendly, so I'm always like, hey, I need some help. You're really smart. Come help me out. So being the smartest guy in the room, not always the best thing. Sometimes, yeah, but you know, if you're not that fun to work with, it's kind of, people are always like, yeah, it's really smart, but, you know. So, yeah, troubleshooting, you're gonna learn it. But it's usually, like Motorola probably has their own standards and procedures on how to troubleshoot. You know, Samsung does it a little different. But yeah, any other questions?
You said you were part of a startup. Like, what do you think goes into like being in a startup, and how are you able to like account for new people who joined in or give them like roles within the company?
Yeah, so that startup was a huge effort. That was when Apple and Samsung were together. And we weren't sending 5 million pennies over to them for, you know, some payment. But as far as about being in a startup, so Samsung is really structured, right? It's like a military kind of hierarchy, right? So for us, it was just this guy knew what he had to do, and he had people under him, and he knew what he had to do. So I was coming in at the very, very bottom, and to be honest, when I came in, I was putting tape on the floor and marking out where new tools were supposed to go, so that when the riggers came in, the movers, right, they knew where to position the tool. But we had very specific locations that had to come because, like if you look at this tool, right there in the front, what happens is there's a whole system that's above our fab that has tracks that picks up the foods, brings them up to the ceiling, and then runs them all over our fab. So our fab was 9 football fields long, so it was not possible for people to sit there and bring a food here and then walk down there and bring it. So we had to have that automation. So the location of the tool was actually very important. You put down these templates and mark it all out, because when they brought in a tool, they bring it in you know, an afternoon. You get about 4 hours with these guys that bring it in. They're like, where do you want it? Right here. And then you have to like push it all together and line it all up. And I mean, these tools are massive. They're really heavy. So. But being in a startup, if it's run right, and there's a lot of project management that's involved. And so for us, it was always knowing your milestones, knowing your goals and what you're trying to accomplish, right? And then we were rewarded for our bonus was associated with how fast we could start it up and how fast we could get our yields up and all this different, they're called key performance indexes. And so we got some really good bonuses with that. As far as startups, it isn't like a startup like a new company where like you guys are all getting together and you have all these brainstorming ideas. This is very rigid, very, we had, 3,000 people working on the same goal, right? Well, not 3, probably half of us. The other half were maintaining the memory side and everything else. Any other questions? So yeah, TensorFlow is just an online program. You can go in there. It's been over a year since I've done it, and I really felt a lot of practice. So if I were to tell you anything about it, it'd be a lie. I really haven't kept up on it. But the funny part for me was I took the UT Data Bootcamp, and everything was open source. So they basically put together a program where you could go do anything that any information that they gave to you, you could go do it yourself. And they're like, sign up for this. It's a free trial. And I'm like, I'm paying $12,000 for free trials. And but TensorFlow is another one, right? You can go out there at any point, and if you do your research on machine learning, you just put in your variables, right? Whatever it is, and then it gives you the output. Oh yeah, neurons. Yeah. So it's very interesting stuff. You do your neurons and you apply it. I couldn't even explain it to you, to be honest. I'm sorry. This is an old presentation that I did for when I applied to Tesla a year ago. I haven't been up to date. I'm sorry. Anything else? All right, thank you guys.